Hello, today I will show you how to design the so-called super tall buildings. Okay, I'm Wei Zhang. I will show you what is the different structural system, what are the different shape efficiencies, and some basic criteria of the design. And actually, the height of the building most likely depends on how many stories of the building you want to design. For example, if this is an office building, most likely the headroom should have a 3 to 4 meters. For residential building, it's about 2 to 3 meters. And then you need to understand the so-called aspect ratio. This is need to let you identify whether the building is a very special building or very common building. Most likely the value is larger than 10. We call there's a need to have a special feature to take the wind loading. Okay, the aspect ratio is the formula is depends on the height divided by the footprint, the width or the depth. Okay, and for example, this is a building B, consider y direction. This is about 10 meters, and you just use the height 200 divided by 10, you will see the value is 20. You can see actually this is a very slender building. You can regard this is a very difficult building for design. And then for the deflection control, the higher we have, the much more deflection we have. That means you can see the height will be, the deflection depends on the power 3 for height. Okay, and then the dynamic building comfort. Okay, you can see different mold shape, and most likely you can say the structural design will be based on the for base or the displacement based or performance based. For the control of the deflection in Hong Kong or in other countries, most likely you just control the H divided by 500. For example, if you design the building is 500 meters, that means you need to control the deflection more than 1 meter, because the formula is H divided by 500. If you design 500, it means 500 divided by 500 is 1 meter. Okay, and then for the building comforts, for residential building is controlled to 10 to 15. You can see the different forms of the buildings. Okay, and this is a so-called Outriggers system you normally see for many super tall buildings. Just show you some different forms of tall buildings. And the first one is a felt, the Eiffel Towers, and then the second one we call the bundles, MegaFrame with Outriggers system, and then you will see this is a Outriggers system. The left hand side is the one without the Outriggers system. The right hand side, the core wall and the column combined together, they form to be so-called Outriggers system, and the column held a loft to reduce the moment of the core wall and make the frame much more stiff. This is so-called Outriggers system. You will see the picture how they work together. And other form is linked and the tripod. And just show you, this is a very common form, is with a core wall and then mega columns with so-called belters connect column together, and also we have a so-called Outriggers system to connect the column to core wall. And just show you the different shape. Sometimes we have do some comparison of their efficiencies. For example, for the rectangular form, most likely the much more efficiency will be the left hand side. We have an edge of columns. For the polygon or circular shape, a polygon is much more better. That's why you can see the Outriggers system. Sometimes you will have 8 columns, 8 numbers of columns. And for the triangular shape, sometimes you can see the comparison. The left hand side with n columns will much more better, and you will see the comparison. And the window, you also can see this is if they are the rectangular building, the wind coefficient is much more higher. It means that it will take much more wind. And if this is a form, is something like this, they can reduce a lot. You can see the reason why we have much more wind, because you can for example, for the this one, this has very square shape, and then you can see many vortices formed after the wind is passing through the building, and it makes the side wind is much more larger. And some forms can help reduce the wind. For example, for the 101 building, they have a rush end corners, and then they can reduce the vertex. And then if there are some openings, it will much more better. And you can see the difference between columns, buildings with openings or without openings. Sometimes if the building can change a little bit, can help to reduce the vertex. And for the super tall building, most likely we will do some wind tunnel tests to investigate the values of the actual wind. That's why wind tunnel tests should be done for super tall buildings. And sometimes we can use the damper to reduce the dynamic load. That's why you can see the 101 building, there's a ball on the middle to counterbalance the during the earthquake shaking. Okay, and sometimes they use the liquid as another form of the reduce the shaking of the building. It's called the liquid dampers. And also in the future, I think you also need to think about the green buildings. That's it for today. Thank you.